This is a short demonstration of the features of Curry 9 and how some typical workflows can be performed. Let's start with performing an acquisition. We're here from the Workflow tab, where Curry presents us with typically used options depending on the state the software is currently in. We can select to create an amplifier configuration, and for all of the amplifiers that the Curry software supports, predefined configurations are already available, but we can also create our own configurations, or we can change configurations, for example, adjusting the sampling rate or disabling and enabling certain channels or renaming them based on the needs of our acquisition. Once we have created an amplifier configuration, we can start an acquisition, which creates a new empty study ready to be recorded into. From the amplifier control dialog, we can again select the amplifier we are using. We can select the configuration we want to use. We can specify where on our hard drive we want to save the recording, and on pressing Start Amplifier, we would connect to our amplifier using the configuration that we specified. And just for demonstration purpose, I will not connect to the amplifier here, but I will actually use the simulator and replay a file that was already pre-recorded. Now, once the amplifier is connected to the software, we can perform, for example, an impedance check to see how well the electrodes make contact with the scalp. Electrodes with a low impedance show up in blue, and electrodes with a higher impedance show up in red. It's also possible to expand this view to the full screen, so it is easier to see the impedance values from further away while you are trying to get them down. Once we are happy with the impedance values, we can stop the impedance check, and Curry has an inbuilt check to automatically deselect channels that are above a certain impedance threshold, but in this example I would just keep all of my channels. Yes, now we can start recording. From now on, the data will be recorded, and you can also see that while data is coming in, we have this little scroll bar down here, which you can grab and drag back to previously received data. This is an epileptic recording, and you already can see some epileptic activity that you find interesting. You can mark them by placing your time cursor on the interesting activity and then pressing one of the number keys on your keyboard to create an event. And I just pressed the type number 1 key, which created a spike 1 event. And by the way, this file has already been marked, that's why we have already events here, but you can manually mark any event that you like. And here in the annotations dialog, you can also see which predefined annotations are possible for event marking. So you can, for example, also mark this as a type 2 spike. So even while you are recording, you can already start scoring the data, although you don't have to do it, but it's an option. Curry also has the possibility to digitize electrode locations, which can be done by opening the digitizer options, where we can connect either an NDI device or a Pulhemus digitizer device. And again, I'm using the simulator for this demonstration. And then have an audio guided workflow that takes us through all of the locations that need to be measured. And if this was a real recording, we would have a stylus in our hand, and now the task would be to measure a point on the left ear that is then later used to co-register the electrode locations to the image data of this patient. And this way we can measure all electrodes one by one. There is also an option to interpolate locations. Let's quickly show you this too, where you already start with a full set of locations based on standard locations that come from the 1020 labels of your configuration or from the amplifier configuration that matches a certain cap. And with this interpolation feature, you only have to measure a subset of locations, and as soon as there are 5 locations actually measured, all of the other locations are estimated, and they are adjusted based on each new location that you measure. So you can very easily just measure a subset of electrode locations and stop at any point when you are happy with the location result, and use this as your final digitization result. It's of course more accurate to digitize each and every electrode, but especially for high density caps like 128 channels or 256, it is also very safe to just digitize every second electrode, for example, and have the remaining electrode locations interpolated. The locations that we have digitized, they are automatically saved with our recording, so we don't need to manually save anything. Okay, for the acquisition itself, we have some additional options. For example, we can apply filters, where we can choose from a set of preset filter bands, or we can define our own user-defined filters and then define the high pass and the low pass frequencies ourselves to remove some of the noise in our data. It is also possible to perform a template matching during recording, where you mark a certain interesting spike from the data that you are just being recording, and then query marks similar occurrences in your data, like for example here. But usually this step is more easily be done in post-processing. Same with artifact reduction. You could put some effort into your signal processing and remove artifacts like eye blinks, but this is also easier done in post-processing. Okay, once we have recorded the data, we can stop our amplifier, and here in the database we can now see the file that we have just recorded.